Hello everyone, this is our second lecture and here we will be solving some problems regarding to circles and chords based on the theorems and the results which we have learned in the first lecture. So this is the lecture 2. So first we will be recalling the theorems which we have learned in the previous lecture. Let's see. Okay. So what was the first theorem which we learned? The first theorem says that equal chords of a circle subtend equal angles at the center. That is, if we are having two equal chords in a circle, then they will be subtending equal angles at the center. That was the first theorem. The second theorem was the perpendicular from the center of a circle to a chord bisects the chord. That is, we are given a chord in a circle, and if we are drawing a perpendicular from the center to that chord, then the perpendicular divides the chord into two equal parts. That is the second theorem. Theorem 3 states that equal chords of a circle are equidistant from the center. That is, if you are having two equal chords in a circle, then their distances from the center will be equal. Okay. What was theorem 4? The fourth theorem states that the length of a chord AB of a circle having radius R is given by AB equal to 2R sine phi by 2. So this theorem gives a direct formula for calculating the length of the chord AB, provided the radius R of the circle should be given and also the angle phi should be known. What is the angle phi? It is the angle subtended at the center by the chord AB. Clear? So let's move on to the next theorem. What was theorem 5? Theorem 5 states that the angle subtended by a chord at the center is double the angle subtended by it at any point on the remaining part of the circle. This theorem we discussed in detail in the last lecture. So the theorem states that if a chord subtends an angle at the center, and if you are taking any other angle subtended by the chord in any other part of the circle, then it will be exactly half of that angle subtended at the center. Okay, this is a very powerful theorem. And the theorem 6 is a direct consequence of theorem 5. Here says that the angle subtended by a semicircle is 90 degrees. Angle subtended by a semicircle means if you are given the diameter of the circle, then it subtends, then the angle subtended by it at the center will be 180 degrees. Okay. So the angle subtended at any other part of the circle will be exactly half of 180 degree, which is 90 degrees. So instead of circle here, we can use the term semicircle because we are considering the diameter and the above portion of it. Okay. So you can say the angle subtended by a semicircle is 90 degrees. So this is a direct consequence of theorem 5. Is that clear? Okay. And the last theorem, theorem 7, it deals with the cyclic quadrilateral. What is a cyclic quadrilateral? A quadrilateral whose vertices are on the circle. Such quadrilaterals are called cyclic quadrilaterals. And it's having a very important property. It is that the sum of either pair of opposite angles of a cyclic quadrilateral is 180 degrees. That is, in a cyclic quadrilateral, if we take the sum of the opposite pair of angles, then it will be 180 degrees. Clear? So these were the important 7 theorems which we had discussed in the last lecture. So here in this lecture, I will be discussing some of the problems related to this theorem. So you will be getting an idea of how to apply these theorems in a problem. Okay. So let's move on to the first problem. So here is the problem 1. So what does the problem say? Okay. So here, a chord AB of a circle obtains an angle 30 degree at its circumference. Okay. So a circle is given. So I have illustrated the problem using a diagram. So a circle is given. So I am taking the center of the circle to be O. Okay. And we are given a chord AB of the circle. So here is the chord AB. And it is given it subtends an angle 30 degree at its circumference. Somewhere at its circumference. I am taking a point C on the circumference. So it is given that it subtends an angle 30 degree, say at C. We are taking an arbitrary point C on the circumference. Okay. This much information is given in the problem. Then the radius of the circle is. Then what will be the radius of the given circle? Okay, that is our problem. And there four options are given. What are the options? The first option is independent of length AB. Second option, the same as length AB. Third option, larger than length AB. Fourth option, smaller than length AB. So we have to find a relation between the radius of the given circle and the length of the chord AB. Right? That is the information which we are getting by reading this option. Okay. So how to solve it? So let's move on to the solution. Okay. So first we are writing the given information. What is given here? It is given that angle ACB is 30 degrees, right? It is given in the problem. So we have written the given information. Okay, so the chord is AB and it's subtending an angle 30 degree at the point C on the circumference. Now what I am doing, I'm just joining the center O to the points A and B. Okay, then we will be getting OA and OB. So what are these OA and OB? These are nothing but the radii of the circle. So our problem is to find the relation between this radius and the chord of the circle AB, the chord AB. Okay. So first, initially, I have joined the points OA and OB. Clear? Then, here what you can observe, just see here an angle is formed at O, right? Angle AOB. What is the relation with this angle and the given angle 30 degree? Just recall the theorems which we have learned, and you should be able to recall those theorems and you should be able to apply it within a minute. Okay, so you should by heart the theorems and you should familiarize the theorems using the diagrams. It will make you memorize it more faster. Okay, so here see the angle formed at the center O. This is the angle subtended by the chord AB at the center, right? And 30 degrees is the angle subtended by the chord AB at a point on the circle. Okay, so we have a theorem which relates this 30 degree and the angle subtended at the center, right? Which was the theorem? Yes, it was the theorem 5. The theorem 5 says that this angle AOB will be double the angle 30 degrees, right? That is, we have written here. Theorem 5 says that angle AOB equal to twice angle ACB, and we know that ACB is 30 degree. 2 into 30 degree, which gives 60 degree. Clear? Okay. Thus, we have obtained this angle AOB. Okay. Now, just observe here. We have already told that OA and OB are nothing but radii of the circles, right? Then we can see that OA equal to OB, right? Okay, that we have written here. OA equal to OB equal to R. These are radius of the circle. Okay. Now, consider the triangle AOB. The triangle AOB. That in this triangle, we have two equal sides. We have already shown OA and OB are equal. Then what type of triangle is this? Yes. Then clearly, triangle AOB is an isosceles triangle. Is that clear? Okay. Then we have a property of an isosceles triangle that the opposite angles to the equal sides will be equal. We have already discussed this result in our previous lecture that if you are having two equal sides of a triangle, then the angle opposite to these equal sides will be equal. Right? Let me mark those angles. So here we can see that these two sides are equal, right? Then what we can say, this angle and this angle in this triangle will be equal. Okay. So let's write that. Therefore, angle ABO equal to angle BAO. Is that clear? Okay. Then we can apply by angle sum property of a triangle. What we can say, these three angles, when it is summed together, we will be getting 180 degrees, right? Okay. See, angle AOB plus angle ABO plus angle BAO equal to 180 degrees. This is the angle sum property. Okay. But here we have already showed that angle ABO and angle BAO are equal. So they can be given the same, right? So how can we write it? We can write it as 2 angle ABO, okay? And also we have already shown that angle AOB is 60 degree. So 60 degree plus 2 angle ABO equal to 180 degree by a calculation. And I believe that you are familiar with this calculations of numbers. And after that calculation, we will be getting angle ABO equal to 60 degree. So we have obtained this angle as 60 degree. If this angle is 60 degree, then clearly this angle will also be 60 degree. And already we have shown that this angle is 60 degree. So in short, what happened? All the angles of this triangle AOB are 60 degree. So what this triangle have become? The triangle become an equilateral triangle. Okay. Triangle AOB is an equilateral triangle. And also we know all the sides of an equilateral triangle are equal. Right? So here what happens? The length of the chord AB will be equal to the length of OA, which is the radius of the circle. So here AB equal to OA equal to R. So the radius of the circle is same as the length of the chord AB. This is the result which we obtain or the answer which we obtain. Here, okay. Then which option will be correct in problem 1? See, here the option B will be correct, right? So let me mark the correct option. Here option B is the correct answer. Is that clear? Okay. So let's move on to the second problem. Okay. So here it says that two parallel chords of length 8 centimeter, each in a circle, are separated by a distance of 6 centimeter. So here we have taken two parallel chords. Okay. and each of the parallel chord is having length 8 centimeter, which means they are equal chords and they are separated by a distance of 6 centimeter. The two chords are separated by a distance of 6 centimeter. Okay. Then we have to find the radius of the circle. So I have illustrated the theorem, the problem using this diagram. So here I have considered two chords, AB, CD, each of 8 centimeter, and the distance between the two chords is taken to be 6 centimeter. Okay, so this is the information given in the problem. We have to find the radius of the circle. First option is 5 centimeter. Second option is 5 root 2 centimeter. Third option 5 root 3 by 2 centimeter. And fourth option 4.5 centimeter. So let's see how to solve the problem. Okay. So here, let me erase all these things. Okay. So here, see, we are taken two chords A, B and C, D. That is written here. Given A, B equal to C, D equal to 8 centimeter. Okay. So in the question, it was given that the distance between these two chords is 6 centimeter, right? So what here we are doing, see, here in order to make this distance, we are drawing perpendiculars from the center to the chord AB. A perpendicular is drawn, name it as OX. And similarly, we are drawing a perpendicular from the center to the chord CD and we are naming it as OY. Is that clear? Okay. Then, so that is written here. OX and OY are perpendiculars to the chords AB and CD respectively. Okay. Then, by the problem, what we can say, XY equal to 6 centimeter, right? Is given. Now, what we can say here, we know that equal chords are equidistant from the center. We have proved the theorem. It was the theorem 3. Equal chords are equidistant from the center. So this chord AB and the chord CD, they will be of equal distances from the center, right? Here given that the total distance is 6 centimeter and this distance OY and this distance OX are equal, which means that each distance will be 3 centimeters. See, by theorem 3, OX equal to OY equal to 3 centimeter. Is that clear? Okay. Also, here we have said that OX is a perpendicular to the chord AB, right? Then we know that a perpendicular divides the chord into two equal parts. This is the perpendicular which is drawn from the center. So here, what we can say, AX will be equal to BX and both will be of 4 centimeter. Similarly, here OY is also a perpendicular. It divides the chord CD into two equal parts. So CY equal to DY. Both will be of length exactly half of 8 centimeter. That is 4 centimeter. Clear? Clear? Okay, but here our problem is to find the radius of the circle, right? So I am taking in particular this radius. I'm joining the point A to the center O. Then OA is the radius of circle. It is not necessary to take this radius. You can take OC or you can take OB. Any one radius is enough. So I am here taking OA. And my idea is to consider this right angled triangle. Okay. So here, see, we have this information by theorem 2. I already told now it that by theorem 2, AX equal to BX equal to 4 centimeter. Because the perpendicular drawn from the center, it bisects the chord. Clear? Okay. So now our aim is to find the radius OA. For that, I am considering the triangle A or X. See, our aim is to find OA. So we are considering the triangle OAX. Okay. So what we can say in this triangle? Okay. So it is a right angled triangle, right? We know the distance of OX. OX is 3 centimeters. And also we know the distance of AX. It is 4 centimeters. So what we can do to find OA? Yes, in order to find OA, we can simply apply the Pythagoras theorem. So here is the Pythagoras theorem. By Pythagoras theorem, hypotenuse square, OA square equal to AX square plus OX square. That is 4 square plus 3 square equal to 16 plus 9 equal to 25, which is nothing but 5 square. So from here, OA square is equal to 5 square. What it says? It says that OA equal to 5 centimeters. So we obtain the radius of the circle to be of the length 5 centimeters. Is that clear? Okay. As I told previously, it is not necessary to take this radius itself. You can take OC. While taking OC, you have to consider the triangle OCY. That is the corresponding triangle you have to consider. Thus, we obtain the radius to be 5 centimeters. So let's mark in the problem the correct answer. So what is the correct answer? Correct answer is option A, right? So here is the correct answer. Clear? So this is all about problem 2. So let's move on to the problem 3. So here is the problem 3. Let me erase this one. So now onwards, you just pause the video and you just read the problem and try to solve by yourself. If you are not getting it, then only you have to listen the video and take hints how to solve it. Okay. Most of the questions, it is because I am doing it in elaborate way. That's why it is taking 5 to 10 minutes to solve one problem. But if you're knowing all the theorems and if you are by hearting it, then it will be easy for you to solve the problems by seeing the diagram. Always, while getting a problem, the first thing you have to do is to draw the diagram. Draw the circle and what all information are given in the question, just plot all those things in the diagram. Then it will be easy for you to find the way how to solve the problem. Okay, so let's see what the problem 3 says. A chord of length 5 centimeter subtends an angle of 60 degree at the center of the circle. Okay, so in a circle, I'm taking a circle and it is given that one of the chord of the circle, its length of the chord is given to be 5 centimeters. And at the center, it subtends an angle of 60 degree. Okay. So here is the diagram. I have taken a circle. There is a chord of length 5 centimeter. It subtends an angle 60 degree at the center. How is the angle subtended at the center? How we will get that? Just by joining the end points of the chord to the center of the circle. Then we will be getting the angle subtended by the chord. Here, that much information is given and that we have plotted here. What other things are given? The length in centimeter of the chord that subtends an angle of 120 degree at the center of the same circle is. Okay. Now in the same circle, we are considering another chord. Say that these two circles are same. In order to understand the question, I have drawn it separately. Okay. In the same circle, we are having another chord which subtends an angle of 120 degree at the center of the circle. Okay. So here it is being drawn. So our problem is to find the length of this chord. Then what will be the length of this chord? Is the question clear? Okay, 4 options are given. First option is 6 root 2 centimeter. The second option 8 centimeter. Third option 5 centimeter. And the fourth option is 5 root 3 centimeter. Is the question clear to you? Okay. On to the solution. So here all the given informations are taken. So first let us consider this chord, the chord which subtends an angle of 60 degrees at the center. I have named the chord as EF, and the center of the circle I took it as O. Then here the chord EF is of the length 5 centimeter and the angle subtended at the center is 60 degrees. So here what you can say about from this given information, can you say anything about the radius of this circle? So here I am applying the same idea which we have used in one of the previous problems. See, so I'm just explaining it. Listen carefully. So here the chord EF is of 5 centimeter, right? And here OE and OF. What are these things? These things are the radius of this circle. Okay. Then clearly this OE and OF, they are equal. Okay. Then we have the property. Then this triangle EOF, it becomes an isosceles triangle, right? Then we have the property that, I will show you. If these two sides are equal, then we have the property that the angle opposite to the equal sides of a triangle are equal. Then these two angles will also be equal, right? Then by angle sum property, the 60 degree plus these two angles, the three angles sum will be 180 degree, right? Just by solving that, we will be getting that this angle will be 60 degree and this angle will also be 60 degree. We have used the same pattern in one of the previous problems. That is why I'm not writing these steps here. I believe that you can understand this. Okay, just by applying angle sum property, we get. Then what this isosceles triangle of EOF? Now it became an equilateral triangle. Here is written here. So in problem 2, it is given clearly. So triangle OEF became an equilateral triangle. I don't know where it is. I think it is not problem 2. It is problem 1, I think. Okay, we just refer to this in one of the problems in problem 1 or problem 2. It is given, the same idea is given there to solve that problem. Okay, so this became an equilateral triangle. This much is clear. Then one of the side of this triangle is given to be 5 centimeter, and also it is an equilateral triangle. Then what you can say about this side and this side? Both these sides will be of 5 centimeter. Thus, we obtained that the radius of the circle will be 5 centimeter, right? So here we obtain OE equal to 5 centimeter, which is nothing but the radius of the circle. So in order to obtain this information, these additional conditions were given in the problem. Here, now the other information which was given in the problem was there is another chord. Let's we name it as AB. It subtends an angle of 120 degree at the center. It has the information given. So our problem is to find the length of the chord AB. To find the length of the chord AB. This is our problem. Yes. But we learned a direct formula to calculate the length of a chord, right? Which theorem was that? Yes, it was theorem 4. So by theorem 4, we have a direct formula to calculate the length of the chord AB, and the formula is given by AB equal to 2R sine phi by 2. Here R is the radius of the circle. What was phi? Phi is the angle subtended by the chord at the center. So here already we have shown that radius r is 5 centimeter. And what is angle phi? Here angle phi is 120 degree. Okay. So we can apply those things here. See, after applying what we are getting, AB equal to 2 into 5 into sine 120 degree by 2, and 2 into 5 is 10. 120 degree by 2 gives 60 degree. So by trigonometry, we know sine 60 degree is root 3 by 2. So by simple calculation, we will be getting AB equal to 5 root 3 centimeter. Thus, we obtain the length of the chord AB to be 5 root 3 centimeter. Is that clear? So the question was pretty easy. If you're understanding the concept, then all the problems will be pretty easy for you. Okay. So the first information given in the problem is just to find the radius of the circle. From that given information, we can easily find the length of the chord AB by the direct formula. Clear? Okay, so let me erase all these things. I think this is not problem 2, problem 1. You just refer to that. Okay, so let's mark the correct option in the problem. So which one is the correct option? The correct option is option B. Is this problem clear to you? Okay. So let's move on to the fourth problem. So here is the problem 4. So what does it say? Let's read the problem. AB and CD are two parallel chords of a circle of radius 13 centimeter such that AB equal to 10 centimeter and CD equal to 24 centimeter. Find the distance between them. And the one of the hint given is that both the chords are on the same side, which means either above the center or below the center, but both the chords should be in the same side. Okay, fine. So here two chords AB and CD are taken and they are given to be parallel chords. The radius of the circle is given to be 13 centimeter. Also the length of the chords are given. AB equal to 10 centimeters, CD equal to 24 centimeters. See, I have illustrated this in this diagram. And also here radius. Let's just proceed. It is given to be 13 centimeter, right? That information is also given. Okay, so this much information is given in the problem. So what is our problem? The problem is to find the distance between the two chords. See, here the distance between the two chords. See, this distance, this is the thing which we have to find. So 4 options are given. First option is 9 centimeter. Second option is 11 centimeter. Third option is 7 centimeter. And the last option is none of these. Okay. So by seeing the diagram, I think you are getting an idea of how to solve the problem. You can choose another way of solving the problem. I will be showing one particular way, but there will be some other way also to solve the problem. So if you are getting some easier methods to solve the problem, of course you can go with that. But the thing is that the concept you are using, the theorem you are using should be precisely the correct one. Okay. So let's move on to the solution. Before that, let me erase all these things. Okay. So move on to the solution. So here is the solution. So I have taken the two parallel chords AB, CD, which are on the same side of the circle. And also the given information is that AB is 10 centimeter, CD is 24 centimeter. So our problem is to find the length between these two chords, right? How can we find this length? There is no formula or no theorem to directly find the distance between the two chords, right? If these two chords were opposite sides, then we could use the concept of drawing perpendiculars and taking the theorem that two equal chords are equidistant. from the center, right? But here the problem is that both the chords are on the same side of the circle. We have to find the distance. Whenever there is a concept of finding distance, the first idea which we will be using will be drawing perpendiculars to the chords. Okay? So here also we are using the same idea. Let's draw two perpendiculars to each chord. So here are the perpendiculars. I'm drawing the perpendicular OP to the chord AB and drawing the perpendicular OQ to the chord CD. Here, draw OP and OQ perpendiculars to the chords AB and CD respectively. So this is our first step. Is that clear? Once we have drawn the perpendiculars, the next step is to apply the theorem corresponding to the perpendicular drawn to the chord. What is the theorem? The perpendicular from the center drawn to the chord, it bisects the chord. That is, it divides the chord into two equal parts. So here, OP is the perpendicular drawn to the chord AB. So here we can say AP will be equal to BP. And the total length is given to be 10 centimeters. So each of these half parts will be 5 centimeters. Similarly, here OQ is the chord is the perpendicular drawn to the chord CD, right? So it also bisects the chord. The total length of the chord is taken to be 24 centimeters. So if you are dividing it into half, CQ and DQ both will be of 12 centimeters. That is given here. By theorem 2, AP equal to BP equal to 5 centimeter, C2 equal to D2 equal to 12 centimeter. Clear? Okay. Now, one more information was given in the problem, right? That is the radius of the circle was given. So here what I am doing, I'm just joining the center O to the point A. Then that will be the radius of the circle, right? And also I'm joining the center O to the point C. Then that will be also the radius of the circle, right? See, here I have joined the center O to the point A and the center O to the point C. Then clearly this OA and OC are radius of the circle, right? See, OA and OC, they will be of 13 centimeter because radius circle, and it is the given information in the problem, right? Now, our aim is to find C. Here, our aim is to find C, this distance PQ. This is our aim, right? So, what idea we will be using here is that we will find the length of this perpendicular OP. Also, we will find the length of this perpendicular OQ. Then if we take the difference, if we minus the length OP with the length OQ, then clearly we will be getting the distance PQ, right? So that is the idea which we are using here. So first, let us find the length of the perpendicular OP. So how can we find the length of the perpendicular? Of course, in order to find the length of the perpendicular, we have to consider a triangle. Okay. So here first, let us consider the triangle OPA. Okay. Consider triangle OPA. So in this triangle, what all things we know? We know this AP. AP is given to be 5 centimeter, and also this OA is 13 centimeter, right? This much information is given. And also this is a right angled triangle. So simply we can use the Pythagoras theorem. So by Pythagoras theorem, OP square plus AP square equal to OA square. And by simple calculation, OP square plus 5 square equal to 13 square. Then by applying these calculations, OP square will be equal to 13 square minus 5 square, that is 169 minus 25, which is equal to 144, and 144 is the square of 12. So what we obtain here, OP square equal to 12 square. So OP will be 12 centimeters. So we obtained the length of the perpendicular OP to be of 12 centimeter. Clear? Now our next step is to find the length of the perpendicular OP so that we can find this difference, right? Now, how can we find the length of the perpendicular OQ? Which triangle should be considered? Yes, consider the triangle OQC. OQC. Here also we know the length of CQ, it is 12 centimeter, and OC is the radius, it is 13 centimeter, and also this is a right angled triangle. So simply we can use Pythagoras theorem. By Pythagoras theorem, OQ square plus CQ square equal to OC square, that is OQ square plus 12 square equal to 13 square. By simple calculation, OQ square will be equal to 13 square minus 12 square equal to 169 minus 144. And this is nothing but 25. And 25 is the square of 5. So from here we are getting OQ at 5 centimeter. Thus we obtain OP to be 12 centimeter and OQ to be 5 centimeter. Our aim is to find the distance PQ, right? We have to find the distance PQ. So here PQ is nothing but it is OP minus OQ. That is 12 minus 5. Then we will be getting 7 centimeter. So the distance between the two chords AB and CD is 7 centimeter. Thus the problem is solved. So the concept used is very easy. But the thing is that the idea should be clicked in your mind suddenly by seeing the problem. And it happens only by practicing more problems. Okay. So the answer of the problem is 7 centimeter. Let us mark the solution. So the correct option is option C, which is 7 centimeter. Is the concept clear to you? Okay. So let's move on to the fifth problem. Here is the problem 5. So let's read this problem. In the given diagram, so here a diagram is already given in the problem. AB is a diameter of the circle. So here AB is taken to be the diameter of the circle and chord CD is equal to the radius of the circle. A chord CD is given and it is said that the length of the chord CD is equal to the radius of the circle. It is also given. If AC and BB are extended to intersect at E. Now, A is joined to C, then we are getting AC. And this AC is extended to the point E. Also, BD is extended to the point E. Then here an angle is formed at the point E. So we have to find this angle. Angle AEB. Our problem is to find this angle. So this is a little bit tricky problem. So we have to apply more theorems to find this angle. So let's see. So let's move on to the solution. Here is the solution. So it was given that the chord CD is equal to the radius of the circle, right? Now here what I'm doing, I'm joining this point C to the center O and the point D to the center O. Then clearly this OC and OD are the radius of the circle, right? And also it is given that CD is also equal to the radius of the circle. So if we are considering the triangle OCD, then all the sides of this triangle are equal, right? Then what is this triangle? This triangle becomes an equilateral triangle, right? Yes, it is given here. Triangle OCD is an equilateral triangle. In an equilateral triangle, what will be the each angle of the triangle? Each angle will be 60 degree, right? So here, this angle, angle COD will be 60 degree, right? So I have taken that. Angle COD equal to 60 degree. Now what I'm doing is that I'm just joining the point C to the point B. Okay, I'm just joining the point C to the point B. Then an angle will be formed here, right? Angle CBD. I can say this angle. Then, is this any relation between this angle COD, this angle and this angle? Can you see any relation between these two angles? See, here this angle is given to be 60 degrees, right? And it is the angle subtended by the chord CD at the center. And this angle formed at the point B, it is the angle subtended by the chord CD at a point on the circle. Then we have a theorem which connects these two angles, right? Then which theorem is that? See, theorem 5. Theorem 5 says that the angle subtended at the center by a chord, it will be double the angle subtended by the chord at any point on the circle. So this angle formed at B, which is angle CBD, it will be exactly half of this angle, right? Therefore, angle CBD is 60 degree by 2, which is nothing but 30 degree. Clear? Okay. Okay. Thus, we obtain this angle and also this angle. Now, consider this angle, angle ACB, this angle. What is this angle? This is the angle subtended by the chord AB at a point on the circle, right? And this chord AB is nothing but the diameter. The diameter of a circle subtends an angle of 90 degree at any point on the circle. We have learned it by a theorem, right? So consider this angle. This angle will be 90 degree. It is by theorem 6. We have learned it by theorem 6 that angle ACB will be 90 degree. Okay. So angle ACB is equal to 90 degree. Here, because the angle subtended by a semicircle is 90 degree. That is the theorem 6. From that, clearly we will be getting this angle to be 90 degree. If this angle is 90 degree, then if I am taking this angle, I'm taking this angle, the darkened one, then both these angles together form an angle of a straight line, right? And they are linear pairs. Then the sum of these two angles will be 180 degree. From that, I can say this darkened angle will also be 90 degree, right? Then angle ECB will also be 90 degree because both of these angles form a linear pair. Is that clear? Okay. Now our problem becomes much more easy. See, now we have obtained this angle to be 90 degree and we have this angle at B to be 30 degree, right? The problem is to find the angle E. And which triangle should be considered so that the angle E will be obtained easily. See, here, consider the triangle ECB. In this triangle, consider the triangle ECB. Here, two angles are known. Then the third angle to find, we can simply apply the angle sum property, right? Then, by angle sum property, angle ECB plus angle CBE plus angle E equal to 180 degrees. See, what is angle ECB? We have just now told it to be 90 degrees. 90 degree plus angle CBE, we have already obtained it to be 30 degree. Plus 30 degree plus angle E equal to 180 degree. Then by simple calculations, angle E equal to 180 degree minus 90 degree plus 30 degree is 120 degree minus 120 degree. We get 60 degree. So what is this angle formed at E? It is nothing but 60 degree. Thus the problem is solved. Our aim was to find the angle E and thus we obtained that. Clear? I believe that now solving problems have become interesting to you. I have chosen such problems which makes you some interest in applying the theorems and proving problems in circles. Okay. So thus we obtained the angle E to be 60 degrees. This is all about problem 5. Okay. So now let's move on to the last problem of this lecture, problem 6. So here is the problem 6. Let's read the problem. Problem is to find angle X. See, a diagram is given and here we have to find this angle. The angle X we have to find. Where capital E is the center of the circle. Capital E is taken to be the center of the circle. Okay. 4 options are given. X is equal to 50 degree first option. Second option, X equal to 45 degree. Third option, X equal to 55 degree. And last option, X equal to 30 degree. So see, what all informations are given in the diagram? The diagram, see, these two sides are given to be equal. BC, CD are given to be equal. E is given to be the center of the circle. And here this angle formed at A is given to be 70 degree. We have to find this angle X. So this much information is given in the diagram. Here. Let's move on to the solution of the problem. So here. In the diagram, first what we are doing is that we are joining E to the point B. We are joining this EB. And also it was given that E is the center of the circle, right? Then this AD and EB are nothing but the radii of the circle. Here, that why you will be having a confusion, why it is called radii, why it is not called as radius. Radii is the plural of radius. Here we are considering 2 radius, so that's why we are using the term radii. Okay. So thus ED equal to EB. Both are radius of the circles and we are taking it to be small r. Now I am joining this point B to the point D. I'm joining B to D. See here BD. Then BD will be a chord of the circle, right? BD is a chord of the circle. And E is the center. Then what we can say here, can you see any theorem? Can you visualize any theorem after joining BD? See here, after joining BD, this 70 degree, it becomes the angle subtended by the chord BD at a point on the circle, right? Then we have the theorem that the angle subtended by a chord at any point on the circle will be half of the angle subtended at the center. So here, what will be the angle at here at E? It will be double of 70 degree. 2 into 70 degree, which is nothing but 140 degree, right? See, by theorem 5, we obtain angle BED to be 140 degree. Is that clear? So we have find ED and EB to be radius of the circle, and also now we found the angle at E, angle BED to be 140 degree. Now just observe this ABCD. What is this? This is nothing but a cyclic quadrilateral, right? Which is a cyclic quadrilateral. Then we are having a famous property, the theorem 7 regarding cyclic quadrilateral, that the opposite angles of a cyclic quadrilateral, their sum will be 180 degree. So here, if this angle is 70 degree, then what will be this opposite angle? It will be 180 degree minus 70 degree, right? ABCD is a cyclic quadrilateral, and by theorem 7, this angle BCD, it becomes 180 degree minus 70 degree equal to 110 degree. Is this much clear to you? Okay. So what was our aim? Our aim was to find this angle X. But see what happened now. After joining BD, this angle X has been cut into two parts, right? One angle, I will just show you by drawing it. See, it has been divided into two parts. One angle is this one, and the other angle is this one. So it has been divided into two parts. So what is our idea is that we will find this portion separately by considering any triangle or something. And then we will find this angle separately by considering any triangle or something. And then we will simply add both these angles and we will be obtaining the angle X. So that is the idea which we are using here. So now we have to choose which triangle to be chosen. To find this, first we will find this small portion. Okay. So which triangle should be chosen? Yes, you can see the triangle. Triangle DEB. Triangle DEB. So what is the specialty of this triangle? Triangle DEB. Here we have already seen ED equal to C. And let's mark it. Here ED side is equal to EB side because both are radii. Okay. So this triangle has become an isosceles triangle. Clear? So this triangle has become an isosceles triangle. Triangle DEB is an isosceles triangle. Okay. Then we have the property of isosceles triangle that the angles opposite to the equal sides will be equal, right? Then which all angles will be equal here? See, angle EBD will be equal to angle EDB. It's a property of isosceles triangle. Opposite angles to equal sides will be equal. Now we can simply apply the angle sum property. See, angle BED, which is taken to be this we got as 140 degrees, plus these two angles. These two angles are same, so we can give the same name for both the angles. But our aim is to find this small angle, right? So we will be giving this name to both. 2 angle EDB equal to 180 degrees, right? Angle sum property. Then this is 140 degree plus 2 angle EDB equal to 180 degree. Then by simple calculation, we will be getting angle EDB equal to 20 degree. So what we obtained this 20 degree, this small portion we obtained as 20 degree. Okay. So some part of the angle X is provided now. Now we have to find this portion of angle X, right? Okay. So for that, which triangle we have to consider? Just observe and say which triangle we have to consider. Yes, we have to consider, see, triangle DCB. Then clearly this triangle is also an isosceles triangle because it was also already given in the problem that these two sides are equal. So this is also an isosceles triangle, and this angle we know as 110 degree. Then the angle opposite to this angle and this angle opposite to equal sides will be equal, right? See, isosceles triangle, and also these two angles will be equal. Opposite angles to equal sides will be equal. Then we can apply the angle sum property just same as we applied in this triangle. Then 110 degree plus which angle we need? We need this angle, and its name is angle CDB. So we will be pertaining this name. 2 angle CDB equal to 180 degree. By simple calculations, we will be getting angle CDB equal to 35 degree. Is that clear? So we obtained this small portion of angle to be 20 degree. Now we obtained this small portion to be 35 degree. So our aim is to find angle X. So now we have to just add the two angles to obtain the angle X. See, X equal to angle EDB plus angle CDB equal to 20 degree plus 35 degree. It is nothing but 55 degree. So this is the answer to our problem. Is this clear? Okay, so let's mark the correct option in the problem. So which one is the correct option? The correct option is option C, 55 degree. Is the problem clear to you? Okay. So till now in this lecture, we have discussed 6 important problems regarding circles and chords and related to its theorems, which we have learned. So all these problems give you a new idea how to solve a problem, how to relate the theorems with the diagrams given. So I request you to practice more problems related to this. And this is a very interesting topic. And of course, you will be finding interest to solve the problems. So this is all for this lecture and for giving all of you best of luck for your future and have a nice day. Thank you.